Hi everybody, thanks for joining this session. Now I will speak, so first of all, I'm Federico Ferrari from Aliwell by Schneider Electric, and I will speak together with Luca Rossi from Biagini Frigoriferi about heat pump solution using natural refrigerant, so CO2, for both retrofit and new installation. We will start with a very brief overview of some normatives in Europe. I don't want to bore you, so we stick just about very generic concepts. And then Luca will also show you some collaboration we did together, Aliwell and Biagini, and showing also some real installations and real case study. So I promise I will be brief. Let's start with the situation in Europe. Here the main topic is the climate change. So European Union has applied some plans to reduce the carbon emissions, especially in terms of greenhouse gases. And the purpose is to low down CO2 and greenhouse gases. Among the worst greenhouse gases, there are the refrigerants. So here why the HVAC and refrigeration market comes into play. Here listed a lot of very numeric and precise goals for from the European Union, aim to reduce by 55% the greenhouse gases emissions in terms of equivalent CO2. The keywords are reducing carbon emissions, electrification by replacing the current burner and heaters based on burning propane and methane, and to increase the efficiency, to do more with less, do more heat and do more cooling with less energy. So very simple concepts. What are the consequences on the market about these plans from European Union? The booming of heat pump market. Why? Because it's a very convenient way to switch from burning gases to use just electricity to produce 3, 4, 5 times the heat from one unit of electric energy. On the left, you see in the graph the explosion of this market. In the last years, it increased a lot in every kind of technology, from air to air, air to water, water to water. There was just a little slowdown last year. The reasons are many. The change in the price of the gas, also some changes in the local normatives in Italy, also in Germany. But everything leads to think that, as you see on the right graph, since the need for heat pumps will be very high also in 2030, if we want to stick with these goals in electrification and reducing the carbon emission, in the next years, probably the market will boom again. And in this trade show, we all can see around how many heat pumps there are installed and presented. So this is about the market situation. Now, we spoke about the heat pumps. Now, a few words about the refrigerant itself, so CO2. CO2 is not a new refrigerant gas. In commercial refrigeration, has been around for more than 10 years, and it's being very common for a lot of refrigeration food chains where they want to be more sustainable. That means the technology in the past 10 years matured a lot. There are a lot of components around, a lot of installation. You see here some numbers of the installed base. It's more common in Europe for sure, but also other countries are coming. So it's a reliable technology. CO2 is a very sustainable refrigerant since it has a very low global warming potential. It's non-toxic compared, for example, to ammonia. And because of some thermodynamic conditions, it can be very efficient also to recover some heat. So it leads to some more creative layouts, and Luca will show some examples, where it's possible to do both refrigeration, cooling, air conditioning, and heating at the same time. Last but not least, since the technology developed a lot in the last years, Also, a lot of layouts have been developed by manufacturer, and so it's possible to reach some efficiency level absolutely comparable to synthetic refrigerant, if not higher. Okay, I leave the word to Luca.
Thank you, Federico. Well, why we decided to expand CO2 use from the refrigeration field to HVAC field? One of the reasons is obviously because the Swiss regulation forces us and all the installers to use only natural refrigerants, both in refrigeration and in the HVAC sector, because we have several customers with a lot of experience in the CO2 field who massively trust in us. And because we started with a Proficus experience since 2019, when we installed, thanks to the collaboration with Honeywell by Schneider Electric, the first integral system. So this year, we started to expand the CO2 use from the refrigeration to HVACR field. And we can guarantee a long-standing collaboration between our company and the Honeywell by Schneider Electric. The electronic controller, in specific the EWCM 9000 Pro, used in refrigeration racks, has been developed in synergy between the two companies since more than 10 years, and it has been developed to be used also in these reversible heat pump machines. And this high level of experience with this device allowed us, Honeywell, and finally also the customer, to have one only controller able to manage this kind of reversible machines.
Yeah, thank you, Luca. A few more words about the controller itself. In such applications, it's very important to have a comprehensive controller able to manage valves, heat exchanger, compressors for such complex layouts. So a more advanced technology comes with a price of a little bit more specific functionalities and algorithm. And to do so, Honeywell developed a series of PLC, where we offer both the hardware but also the support in developing the software. And for example, this was developed hand by hand with Biagini Frigoriferi. Some specific logic requested from the customer and also suggested by our expert center. In this case, we use the platform TM172, which is a modular platform, very flexible since it has a main board, and it's possible to combine a lot more expandable boards with IOs, valve drivers, backup batteries for the valves, also different HMI for more clarity with the system, and also for the support and the installers to fine-tune the units on field. These logics guarantee a stable pressure operation, very important to achieve the required efficiency level. Also, they can modulate several compressors, another feature that can save some energy, having the exact required load in each moment. And also some of the fruits of the experience from our expert center for some commercial and industrial application, which have been leveraged in this application for Biagini. Okay.
We had to face several challenges. For example, the efficiency of these machines must be even better than traditional reversible or not heat pumps. This kind of machine must be polyvalent machines. Also, I can add, able to run in hybrid mode, so chiller in heat pump at the same time, so able to satisfy all the energy requirements of the store, at the same time air conditioning, space heating, hot water, and so on. Going more into detail, for example, the on-off of this kind of machines don't depend more on increasing and decreasing of the suction pressure in the unit, but only on the digital input coming from an external regulation for example. The management of high pressure was a real challenge because with this kind of a unit, we don't have the gas cooler volume able to do a sort of a buffer, able to dissipate the pressure wave coming from the compressors. So the high pressure valve management was a really challenge, but we are extremely satisfied of Halliwell by Schneider Electric firmware. And this high pressure management has been developed in a sort of three-part collaboration among us, Halliwell, and the Polytechnic of Milan, who did a customized firmware which guarantees in all operating conditions the maximum level of efficiency, so the maximum level of a COP. How we entered in this market? We wanted to enter proposing in the market a unique selling proposition based on our more than 10 years log data know-how and experience in the CO2 transcritical knowledge, to enter in a new market, to achieve obviously new customers, and existing and new customers can be satisfied thanks to this new after-sale service, because we are used to guarantee 4 hours every day after-sale service in all the refrigeration installation we make, sort of the diversification, and the reliability of these reversible heat pumps strictly derives from the reliability of refrigeration compressor racks, which are have a very high level of reliability. Now let's go into detail to the first installations we made. The first of all was Migros Agno, a medium-large shopping mall in the Italian part of Switzerland, close to Lugano, when we installed 2 identical reversible air-water heat pump. In this brief chart, I highlighted the water temperature level. So, for example, in this existing shopping mall, we produce for space heating water up to 37 degrees, and we cool down it during air conditioning operation to 8 degrees. The COP and the energy efficiency ratio are indicated in this chart, and the external evaporator gas cooler in the same devices. Even this kind of device has been properly developed thanks to the collaboration with Luve. So in that same device, we have a double coil able to run in evaporator and gas cooler mode to optimize even the defrosting cycle. Second one, similar to the first one, but with lower capacity and for 100% outdoor installation. 2 reversible CO2 heat pump with a capacity of 320 kilowatt in heating and 380 kilowatt in chiller mode, able to produce water for space heating up to 45 degrees and to cool down it down to 7 degrees. And even in this project, the evaporator gas cooler are air Luve devices. The third one, not yet installed, 2 identical reversible heat pump able to produce water at more than 60 degrees, so 65 degrees, both for space heating and hot water, which will be installed in the Lugano railway station. And the last but not the least, a reversible CO2 water heat pump fed by lake water of Lugano, able to produce hot water up to 65 degrees. Even in this installation, you can see we can highlight a very high level of energy efficiency ratio in chiller mode, because thanks to the lake water, this kind of unit in summer, so in this operation mode, are able to run in subcritical mode. all these installations are examples of existing buildings. So what we want to even highlight is that the CO2 reversible heat pump for medium-large capacity are suitable not only for new building, when obviously the conditions, the temperature, the water temperature required are better, but even for existing building when maybe the store, the building of the customer needs water at very high temperature. Thanks for your attention. If any questions? Yeah. Yeah. Well, we started in 2020. The first installation has been done in 2021. So during pandemic, we never had boring days because we developed this very important project together with anyone.
So it's not this great.
Well, this kind of installation cover a very different range of installation, because the first one is a shopping mall, not the supermarket, but the whole surface of a shopping mall. The second one was a furniture store. The third one at the railway station, and the last one even a shopping mall in the center of Lugano. So I want to highlight again that this kind of solution is suitable with a very wide range of final destination, with a very wide range of water temperature required.
What's this? Does it provide heavy seating and domestic water?
Yeah, not in all the projects, but for example, in the last in Cop City Lugano, we provide both hot water and space heating water at quite the same level. So, for example, space heating water temperature required is around 60 degrees, and hot water requirements is obviously higher, up to 65 degrees. External temperature, so the design external temperature. Obviously, in this kind of solution, the external temperature is the water lake temperature. This is very, very, very high or low, depends, in winter and in summer conditions.
Sure.
Okay, thank you very much. If you're interested in discovering our range of PLC and parametric controllers for both refrigeration and heat pumps, please come to visit at our Halliwell by Schneider booth. Thank you all.